Hi everyone, welcome to Skilled Inspirational Academy. This is free CCNA day 2. So here's the course content, what we're going to discuss today. The first topic is, last time as I told you, I did a lab for accessing the Cisco routers and switches through HTTPS. There is, as I told you, there are three possibilities to access a device. The first thing, let me open the whiteboard. You have three possibilities to access the device. One is through telnet, and second through SSH, and the third way you can access the routers and switches through HTTP and HTTPS. HTTPS is a secure connection. All the information will be encrypted. Say, for example, this is your PC and you're connecting to your router. All your information will be encrypted using HTTPS. So we have a lab today. So I'll show you the lab, how exactly we can access the device through HTTP and HTTPS. So generally for CCNA, we practice the topology in three ways. Okay, one is through the first thing they generally use GNS, that's called as graphics network simulator. But that's not deprecated, but people they start using a tool that's more advanced, that's EVNG. The one we got now is EVNG now. Can you see this is EVNG? These are the two tools. This is advanced and more capable than packet tracer. Okay, let's get started. So I got a Windows PC here. I'm running Windows, and this is VIOS, a virtual iOS running in a router. So this supports the HTTP. And HTTPS can be enabled here, but whereas in the packet tracer, the limitation is not allowing us to, run these specific commands. The HTTP and HTTPS cannot be run in the packet tracer. So that's the reason we are doing this in the EVNG lab. So let me open the prompt. So I've already opened a prompt here. I'll do a lab one more time, but for now, I'll show you how to do this. First, I got a prompt for this router, the router here. So let me show you the config. I'll show you the configuration, what are all the configuration that's needed to, log in this device. So I have to enable a password. That's enable password. I should have to access the HTTPS connection. To make a HTTPS connection working with this router, I should have an enable password. So the command we discussed last time, right? The command is to show the running configuration. That's the everything when the router boots up, the router, all the configurations will be running on the RAM. And the command to check the configuration in the RAM is show running config. This lists out all the configuration. So the configuration which I am interested here is HTTPS. So for that, the basic criteria, as I told you, when you want to make an incoming traffic, example, this is your router now, right? So your HTTP and HTTPS, these two are the incoming connections now from a PC. So in the lab, that's Windows. From this Windows 7, I'm trying to access this router through HTTP and HTTPS. So what else I needed first? To make this connection, the very first thing I should have is an enable password. So they say this is the basic authentication for HTTP connection to this router. This is all incoming traffic, right? The traffic coming from this Windows PC to this router. So this is a first step. You have to enable the password. That's enable password. In this case, I have enabled the password here. This is the enable password. So I did that. And second thing, I should run this configuration in the configuration mode. As we discussed last time, the first mode is enable mode. Since so many people, they are fresher and they are just getting started, they don't know about this commands. So I'm repeating this. So once we get familiar with this, we'll jump right into the config. So first mode is enable mode, and then privilege mode, and then global config mode. So right now I am in the configuration mode, right? So you can see the difference with the icons. I mean, if it is a greater than, it's an enable mode, and if it is an hash, it's privilege mode. Okay, so now first thing is I should have the enable password, and then secondly I should have, first is I should have the enable password, and then secondly I should have the command IP HTTP server. This command makes this router as HTTP server. So what happens? The port 80 is open now. This is all the logical ports, not physical ports. Inside this router, inside your operating system, the Cisco iOS, this port is open for the incoming connection, the HTTP connection. So I'll show you the config now. So show running, and this is pipe command. You can filter in the show running config. I'm filtering the command which I'm interested in. So I'm interested in HTTP. So I should give a command include. In the show running, just I want to include the HTTP configuration. If I give that, see, HTTP and HTTPS both are enabled. This is HTTP and this is HTTPS. IP HTTP secure server is HTTPS. Both connections I have enabled. So a traffic from any source, HTTP and HTTPS, both are allowed. All right, so from the PC, now this router will be responding back to this HTTP requests. Sorry. Let me try to find this here. So HTTP and HTTP secure server both are enabled, right? So now I'm going into this PC, right? This is my Windows PC. If you see in the topology, this is a prompt. When I click on this, it asks me to open. So I am in. So I'll initiate a new HTTP request from this PC. I'm trying to access this device, right? So what is the IP address of this router? So I should definitely have a connection, right? It's an identity. So for example, this router, I got a connection back to this PC, Windows PC. But anyhow, to access this device, I should definitely have an identity. That is an IP address, right? There should be an IP communication, only then I can reach this device. I'll show you the IP address which I have assigned in the router. So the command is show IP interface brief, a brief information about the IP assignment. And the very important thing you always look, I mean, you should look when you give the command show IP interface brief is something, the status should be up and the protocol should be up. Only then your connection is going to work. So let me do a self ping. That's I can reach this device. Yeah, I can reach this device. This is a self test, right? Self ping. So from this PC, I'll try to ping first because that's my first communication. I should try. So I'm going to this Windows PC and I'm going to give a command show IP config, right? This will give me all the IP related information. So this is the IP address that's been assigned, that's connected to the router. So this is the connection, Ethernet 0. I've assigned an IP address in this particular NIC. This NIC has been assigned with the IP address, what we are looking in the prompt. Inside your physical NIC, you got an IP address assigned. This is all called, Ethernet adapters. You got, everybody might be familiar with this, right? In the very first class, we discussed about the physical NIC and the wireless NIC. So in the Ethernet physical NIC, you connect your RJ45 cable, whereas in the wireless NIC, you connect your, laptops using wireless connection. So now I got a physical NIC and I have assigned this IP address into it. How do I check that? I have to go inside the prompt, and if I give IP config all, so this local adapter, Ethernet adapter, it means a physical, and this has been assigned in the same range. So this is the IP address of the router. That's a gateway, my next stop. And this is the IP address assigned to this PC. Because both should be in the same IP range, right? Because my router and this PC, both should be in the same network. So I have assigned here this particular interface for the router. I've assigned as 10.1.1.1. And for this PC, I assigned the IP address. I've assigned the IP address in the same range, 10.1.1.10. So both are in the same network. Now my IP communication will happen between the router and the PC. The communication will happen back and forth. So let me test from this PC. I can, from this PC, I can reach the router first. The IP address is 10.1.1.1. Yeah, I can reach, right? So in the enterprise network, even for the HTTP connection, you're trying to establish your HTTP connection, and if you're still feeling like, okay, the reachability is not happening. Say, for example, if you're trying to reach 10.0.0.2, and there is no such host in this network as 10.1.1.2, no IP, active IP. So how do you find that? So this is a tool called Packet Tracer, where you can filter the traffic. So everybody might heard about this, but giving you a little more information about that. So this is Wireshark, where you can capture your packets. This is very helpful for troubleshooting. This is not much needed for CCNA, but this is an additional information we are giving you. So this is how in the enterprise, they try to find what exactly the problem is. You will get an high level understanding, and the packet flow, you can find everything through this tool, this Wireshark. So from the Wireshark, I can I can look into the packet. Very deep level of packet inspection is possible with Wireshark. So every protocol, whatever the protocol it's used, you can filter the traffic based on that. So now we are doing an ICMP, right? We are doing a ping. If I give ICMP, can you see? The first thing, when I try to reach, the destination is unreachable. So now I can reach the router 10.1.1.1. the IP address of the router I can see from here. And 10.1.1.10 is the IP address of the PC. So who is making a request? From there, from this router, I'm making ICMP request. And I get an ICMP reply, right? For every packet you can see here. If the destination is not reachable, you can figure out from here. The destination is not reachable. Very useful tool. Definitely you get used to this. For enterprise support, you definitely have to have this tool installed in your PC for troubleshooting. For CCNA, as I told you, this is much, but this is very good opportunity for you guys to see the live troubleshooting with Wireshark. So that's it. And I've shown you the ping. Now we'll go with the HTTP, how to initiate the HTTP connection. So the command which I have to give is HTTP first, // and the IP address of the router, and then /. If I give that, can you see? I logged into this router. So what happened from this PC? What exactly I did inside my Windows? Yeah. From the PC inside the Windows, I just went into the browser and initiated the HTTP connection from this browser. And what happens? This goes to the router. Because I have configured 10.1.1.1 IP address, and this PC is assigned with 10.1.1.10. So the traffic is going from PC and in Windows and opening a browser and initiating a HTTP request, and it goes to the router. And as I told you, I should have two criteria. One is enable password, and then I should enable the HTTP. So both are enabled. Now I have an access to this device. So what I can do inside, this is execution mode, right? So from here, let me try to run a command, same command that I use to check the interface status, show IP interface brief. Can you see that? I can see the same output which I can see from the CLI. Right, in the CLI, I can see show IP interface brief will give me the interface detail. The status is up or down, and it is sort of admin down. So I can see all the details here right from my browser through HTTPS access. Sorry, HTTP now. Can you see this is configuration? You can do configurations also. That is also possible. You can change the host name. You can do the interface configuration. Everything is possible. So this proves my connection, that I have a HTTP connection to this device. And what are the additional information I see here? So you should have privilege level 15. That's the highest level you should have. It's like a tree. For some being, they won't give access to make changes in a device. You need some sort of experience. And for some, there are different categories. All the teams cannot manage the devices. They have certain limitation, something the only a specific team can do the configuration and other teams can do only monitoring. So in that case, this privilege level helps a lot. So privilege 15 is the highest level. You can do the configuration in privilege level. If you reduce the privileges, you cannot do everything. Say, for example, if you got a privilege of 10, you can just run show commands, not configuration. So now I got a privilege level 15, and I'll show you where exactly that should be configured. If you show if you give show running section user, you see this, I gave privilege level 15 for this user. And this is very important. As we discussed last time, this is local username and password. That's local to this device. This is local to this device. When an incoming connection that comes into this router, when an incoming connection comes to this router from anyone, any incoming connection, so it checks the local database credentials. So this credentials being used by HTTP there. Since I got privilege level 15, I'm allowed to monitor as well as I can do configuration. Both are possible. If I reduce the privilege, apparently you won't get privilege to configure the devices. For now, I have given 15 and you can make changes to this device. Let's now jump in and see we can initiate an HTTPS connection. And before that, let me open a Wireshark and show you the HTTP traffic that's going between the PC and the router. Let me try to initiate the traffic. Can you see this? This is an HTTP connection with response code 200 is successful, right? So for, sorry, you would have seen a different type of HTTP codes. When you access a device, 404 error, that's server error, not reachable. So called HTTP codes. So this is HTTP code 200. It means that you got a successful connection. So I see a successful connection between the router and the PC. What is the command I should use here? Inside the filter, you have to give http.response code. It will show all kind of response code. And since I made a connection with this from this PC to this router, since the connection is successful, I see the code 200 here. So I get a successful connection back. So let's try with HTTPS connection now. This is secure. If somebody is trying to sniff your packet, what exactly the inside this HTTP connection, you can actually, they can see what is the traffic flow and they can sniff the packet. Whereas with the HTTPS, you cannot. You see this? It's showing me that I'm trying to access Cisco. That's the iOS, the devices, the show tech commands, and all that. It's not safe. It's very vulnerable. See, it's showing me the privilege level I have assigned and the ping and everything. They would come to know what exactly happening, what kind of packets being exchanged between source and destination. What is the protocol used? This is vulnerable, right? So this is not recommended. So that's the reason even for many websites, all the websites that's been transformed to HTTPS. Nobody is using HTTP. Very, very less websites there keep sticking with HTTP connection. So now let me try to initiate a connection with HTTPS. Same command, same IP address, only changes HTTPS here. Sorry. only changes HTTPS here. See now the connection. I can see the connection, right? Let me log into the Wireshark and try to filter the HTTPS connection. Okay, HTTPS is not a valid filter. So I'm going to give HTTP dot response code. This is again showing me the HTTP connection. 1 minute. I'll get back to you with this HTTPS filter, guys. I'll look at the HTTP, how exactly we can filter out the HTTPS. I'll show you the next class. But this is how you can filter the packet. And let me try to do an IP dot address equal to 10.1.1.1. Let's try to so again showing me only the HTTP connection here. Actually, this is a HTTPS connection, but I'll come up with a protocol exactly explicitly. It shows the HTTPS. But you know, this transport layer security, this is used only by HTTP, yes, not by HTTP. So I'll just give an overview like what happens. So when you try to access this 10.1.1 is my device. So it's sending in server hello and client hello, and all this packet should be exchanged. This is called a Cipher Exchange. Inside this, the encryption will be, you know, when both end all the encryption protocols should be matched. Only then it establishes a connection. This is more for your CCNA exams. This is all we are giving you more understanding and, you know, in-depth understanding about the HTTP and HTTPS. So in the CCNA syllabus, if you see, you would actually see only how you can initiate a connection through HTTP and HTTPS. This is all giving an additional information for better understanding. It's a packet level of information that, you know, helps you a lot doing a troubleshooting, as well as this leverages your learning. So I'm just giving an overview because this will become a more and you will confuse. So generally the server hello and client hello should happen, and it will share the ciphers. I mean, all the encryptions, protocols, whatever that's been exchanged between source and destination. If both matches, then it establishes a connection. This generally happens only with, you know, as I told you, only this happens through HTTPS. Because no encryption with HTTP. No encryption. I'll show you in the next class, I mean, how exactly to filter this HTTPS. So for now, it proves my connection. Both through HTTP and HTTPS, I can access the device. Let's go into the next topic. First topic we have done, and let's talk about the tier 2 architecture. Let me open up my whiteboard. What is tier 2 architecture? So for every, even if you want to build an apartment or maybe a small house, whatever, you should definitely have to have some kind of layout or something like building blocks, how exactly it should be done. In the same way, not only in Cisco, for all the products, you have some hierarchical approach. You cannot have your devices connected right away. There is an approach. So everybody is following. And here we'll discuss about tier 2 architecture. What is that? So let me go from one by one. So we got a physical layer, then access layer, then distribution layer. Why do we need this layer approach? I'll tell you. So I got my router here. I got a switch. And I have PCs connected to it. Pretty simple design. Since we have been discussing about all this routers and switches, I think people might be a little bit familiar with all this. And I got an internet connection. But this is a switch. And this is a router. So this is my router. This is all PC 5. So we call this layer as a physical layer. And this is called as access layer. And this is distribution layer. In this case, for this specific topology. So this is called as tier 3 architecture. Now let's discuss about why we needed tier 2 architecture. So there are, switches. Basically, everybody, they know it works only with MAC address. It doesn't know anything about IP. So from the networking standpoint, we would say it's a layer 2 device. Because in the layers, the OSI layers, we have a separate topic for it. I'll explain what is OSI and TCP IP layer. Here, the L2 device is always that works with frames. They say it's frames. Layer 3 device, IP address, and layer 3. Because this works on network layer. And this works on data link layer. Now, how the packet will be moved? Based on the MAC address. Here, the packet will be forwarded based on IP address. Forwarding decisions will be based on IP address, whereas in the L2, it's MAC address. So this is switch, right? But whereas router is purely, sorry for that. So the router is a layer 3 device. Purely works on IP address. So giving you a recap about the L2 and L3 device, and let's come to tier 2 architecture. So in the tier 2 architecture, there is one more device that's called a multi-layer switch. Multi-layer switch. What it does, it can work as a layer 3 and layer 2 device. It can work as a router as well as a switch. So instead of 3-tier architecture, I am squeezing my architecture and making it as a tier 2 architecture. A switch, layer 3 switch, and a layer 2 switch. and I got my PCs connected to it. So what is the ideology now? Why do they need layer 2 and layer 3 design? There should be some kind of ideology and logics behind this, right? When they made when they developed, they should have something in their mind to make it a very sequential approach. So all your IPs that sits in the layer 3 device, all your IPs sits in the layer 3 device. That's ideology. Something I would say it's a gateway. All your gateway will be sitting in the layer 3 device. So here you got just, the VLANs. So I would like to give, little more information about VLANs. So all know LAN, local area network. But what is VLAN? It's virtual local area network. But just with the definition, I cannot understand what is, virtual local area network, right? So we'll jump in deep about what is VLAN. Say, for example, your manager is giving you a switch, but you got two departments, very simple design. So one is HR department and one is finance department, but you got one switch. So what is that? Generally it's called as one network, right? You can make it as one network, but the users are very less. Okay, so there are, basically there are two types of switches you generally get in the market. One is 24 port switch and 48 port switch. They may be more, but the most commonly used switch ports are 24 port and 48 port switches. So, but now the manager is saying that I should have two different networks, one for HR and finance. They should not talk to each other. Only the HR, the people who are in the HR department, they should talk to the HR department back and forth. But this user should not talk to finance users. If you want to make such kind of isolation, that is possible with this switch. Well, switches can be classified into two types. Okay, so one is manageable switches. Another one is, unmanageable. Unmanageable switches. What is that unmanageable switches? What we got in the home network. You don't have much control about that. Say, for example, if you connected your PC here, if it is an unmanageable device in your home, so what is the maximum you can do? You can just see the lights. If you see lights on the port, okay, I got a physical connection. If there is a light, but still you cannot communicate back and forth, or you cannot connect to internet, you cannot do any kind of troubleshooting because you are very much limited, and this particular operating system that's run in your home switch, it won't give you much insight about what's exactly happening inside. So that's the reason the enterprise, they are switching into manageable switches. It's an overview again, and let me draw again. So this is a switch. So now your manager is given the switch and he want to make two network, one for HR and one for finance. So here comes the ideology. So now I want to split the switch into two different network logically. Physically, you cannot see that. So logically, that is possible. That's where the VLAN comes in. Virtual local area network. So what happened? This part of ports will be assigned to HR department. Sorry, and this part of network will be assigned to finance department. Okay, sorry. I'm feeling a little bit cold. Sorry, I'm coughing. So you can split into two different networks, HR and finance. So this traffic, the users connected to this specific port, example I'm saying, and if you want to make any restriction or security policies, you have to apply, you can apply this. Only possible if you split into two network using a VLAN. If I make it as a whole, as a one single network, because from right, it comes with the default VLAN 1. That is one network for the whole switch, right? One network for the whole switch. But if I want to split, I should go with VLAN. So now this part of ports will become example VLAN 2, that is HR VLAN, and this the ports here, right? This will become, finance ports. Only the users can talk to finance people here. So this is the basic ideology of VLAN. From the network standpoint, how they would say, they say it is, broadcast domain. The switch comes with one broadcast domain, and you can, divide into multiple broadcast domains, multiple VLANs. Multiple broadcast domains. That is possible. You can create, the VLANs has some limitations. The VLANs you can create from 1 to 4,000 plus VLANs. You can create 4,000. So you have the capability to create 4,000 plus networks inside the switches. Mostly they won't own such a huge networks, but mostly it depends on the enterprise. You can leverage up to 30 networks, 40 networks maximum. Even though this is given with 4,000 network possibility, if you make one switch into 400, what happens? The throughput, the performance will be completely degraded, right? So that's not the best practice. So now I'll show you the lab. I'll show you the switches and VLANs in the lab, so you'll understand better, more practical view of doing VLANs. So I'm loading the switch. So now the switch is booting from the image that's running on the switches 2960 LAN base SE4. So now the switch is loading the iOS from the flash. Still loading. I think there's a problem with the switch. Let me turn off and turn on again. There's no power buttons. What happened? Try to open one more switch. Let me close the packages and open it again. Now I can see the iOS booting from flash. So what is the command I should use to check the VLANs? The very useful command, show VLAN brief. Like the show IP interface brief, the show VLAN brief will give the brief history, or maybe, the brief configuration about the VLAN. If you give this command, it's very simple command. Okay, so the VLANs, there are two types of VLANs. One is layer 2 VLAN, and another one is layer 3 VLAN. So as I told you in the very beginning of the class, always layer 3. It means you can assign IP address to it. So this L2 VLAN, no IP. That's a big difference. You should, everybody should know about this. So I am in the privilege mode now. I'm going to configure VLAN. So I'm giving VLAN and question mark. So you can create 1 to 4094 VLANs, and these are all the VLAN that's reserved and cannot be used. You can use from 1 to 1001, and then 1006 to 4094 VLANs. In this case, for testing, I'm giving it as a VLAN 2. So guys, this is VLAN 1. Okay, this is untagged traffic. So this is a very important question. The people definitely ask about this in the interview. What is tagged and untagged? Say, for example, you purchase a cloth, maybe a t-shirt or whatever from a store. It should have a price tag, right? Something like you can imagine in the same way how you are differentiating the packets. How I told you this is for finance and this is for HR team. How are you going to differentiate this? With the tag, with the number whatever you give here, that's the tag. For finance, I'm saying VLAN 2 example, and for HR I'm telling VLAN 3. So I tag this VLAN 2 for finance and VLAN 3 for HR, and nobody can use this. So what generally happens, whatever the ports here, if I tag this port to VLAN 2, this will be a part of VLAN 2. Say, for example, this user always wants to be connected into finance, always sitting in finance. So I'm tagging this based on the identity, the number. So this user will be assigned back to VLAN 2. I'll show you once we are done with the configuration, you can actually see these ports are going back to the specific VLAN, the customized VLAN which you configure on the switches. So now I'm making this a finance VLAN 2. The identity number is 2, and the name I'm giving finance, right? So if I give the command, same command, show VLAN brief. See, I created the VLAN and I didn't assign any ports to it. So what happens in the L2 perspective? I was saying L2 perspective, you got an access switch. As I told you, this is just an L2 switch. Just forward the frames, no IP. So these are all the ports on the switch. And now I want to make this specific port to finance. Yeah, make to port the finance. So what I would do inside the port, I should do a configuration, right? So what I should do? Config, then config interface and the respective interface ID, followed by switch port mode. What mode? Access mode. As I told you, this is all access layer switches. Access followed by VLAN, followed by the VLAN number. So here VLAN 2 is for finance. So this becomes a finance port. So three things. I have to create a L2 VLAN first thing. And second thing, I should assign the port. Very simple. Create an L2 VLAN and assign the port. It becomes a part of that VLAN, this logical VLAN you're creating. You understand this is very easy to configure. So now first step I did I have created the VLAN, L2 VLAN, and now I want to assign the ports. So how do I check? I'm working from remote, right? I cannot see the ports and the switches. So what's the command I should give? Give show IP interface brief, give you the port information for all the switches. So for example, here I have to take this port. I want to assign this port for finance VLAN. Command from privilege mode, configure. Then I want to configure the interface. So interface configuration and the port ID, this port. Copy, paste, enter. So command switch port mode. First, you have to make the port as an access port. Switch port mode, access, then give question mark, enter. So it became an access port now. So switch port, access, right? Then VLAN 2. If I give show VLAN, can you see this? All these interfaces are bounded to default VLAN 1. And now this VLAN 2 has been assigned to VLAN, sorry, this fast Ethernet 0/2 port has been bounded to VLAN 2 now. But earlier it was with default VLAN 1. So what's next? I have to create one more VLAN, right, for HR. What happens? I should give a command VLAN. Again, I'm creating L2 VLAN. I'm giving a VLAN ID 3 and the name finance. So I gave the same name twice, right? So that's the reason I get an error. So what I should give here, I should give name HR. Name HR, right? Now I'm not seeing any errors here. I'm not seeing any errors. So now let me run a command again, show VLAN brief. Can you see this? I have created an L2 VLAN, but now I need to assign a port to it. Only then the specific port will be a part of it. So how to bind that? As I told you, you got a VLAN, L2 VLAN, created, finance, and then I have to bound a port, right? Two things, create an L2 VLAN first, then bound a port to the specific VLAN. So let me give config. I'm getting into the interface configuration. Let me type fast Ethernet 0/3 here. Copy, paste fast Ethernet 0/3. First command, switch port mode access. I want to make it an access port. Since it's an access layer switch, access switch port, access VLAN 3. Let me run a command again, show VLAN brief. Can you see this? The VLAN, the port 3 has been bounded to VLAN 3. Now, being in the same switch, right? Being in the same switch, this is assigned to finance VLAN, and this becomes an HR VLAN. So I got two networks now, 1, 2, the same switch. This becomes finance and this becomes HR. Logical segmentation, right? So both are done. So what's next? I've created an L2 VLAN now. I'm going to create an L3 VLAN because L2 VLAN just forward the frames. How the IP communication happens? It should have a gateway, right? So that comes in the L3 VLAN. IP address assignment. So make it very simple, this is the user connected here and he should have a gateway. So that's called the L3 VLAN. And this is not a physical interfaces we are going to create now. See for example, this is all the physical interfaces where the PCs are connected, right? Whereas when you create an interface, something like interface VLAN 3, this is a logical interface. You cannot see this. This is logical interfaces just created for communication. So once you create an interface VLAN 3, the layer 3 VLAN with an IP address, example 10.0.0.1, the subnet mask is 255.0.0.0. So what happens? This becomes a gateway for this VLAN. What VLAN is VLAN 3? So for if the HR from this port, the PC wants to communicate back to its gateway, it should come all the way back to this VLAN because here I assigned the IP address and this becomes a gateway for communication. So that is the ideology of layer 3 VLAN. So how do I create that? Configure interface VLAN to gateway for finance, right? So you can always make a description inside the interface. So I'm making a description, something like finance. Just for your identity, how to check that, I'll show you. I've created a VLAN 2 as a gateway for this L2 VLANs, and I need to assign an IP address, right? So this is 10.0.0.1 and 255.0.0.0. Then what happens? If I give a command show IP interface brief for VLAN 2, can you see this? Status is up and protocol is down. Why is that? Because when you create a VLAN, what generally happens, this interface VLANs, you have to be very careful in the production environment, because I face this issue many times. If you create an interface VLAN, you should at least have one active port connected to it. Here in this example, all these ports are down. No physical devices are connected to any of the ports that listed here, right? So I should definitely have one active port. It means that, say for example, this port is assigned to VLAN 2 as an access port, should be connected. Only then the protocol status will become up. What happens now if I try to ping this IP? What do you think? This IP will not be reachable now until we get an active address. Ping 10.0.0.1. I cannot, right? Because the protocol is down. Because as I told you, you should have one active connection, one active port that should be assigned, and it should be up and running. Only then this gateway will reachable. So what should we do now? We should connect at least one PC. So before that, I'll create one more VLAN that's called as interface VLAN 3, right? Description. What is the VLAN I've created here? Finance and HR. So description, I'm just giving in a HR. IP address, let me give 20.0.0.1. Different network. Same switch, different network. So the command, you should show interface description. Oh, this is not show interface description. I think it's not supported in packet tracer. In the real devices, you have this, you can run this command. Yes. to show interface description. The real device that's possible, I think the packet reset limitation, it's not allowing us to, So inside this description, you can see the description here, this column. Now nothing is defined here. So for example, if I create a description for interface gigabyte 0/0, making a description as CCNA, if I give a command show interface description, can you see this? This is custom name. You can have your own name, whatever you want. So this is show interface description command. Since packet tracer is limited, we are not able to see that. So now I've created VLANs, L2 VLAN and L3 VLAN both. I have to check both first and then give show VLAN. So I created L2 and VLAN. So I have assigned this ports. Now what else? I have to go connect the devices back. So I'll get 2 devices here. So let me check what are all the ports I have bounded, right? That's important. Only the specific port will be assigned to the specific VLAN. I cannot go randomly connect the ports. So fast Ethernet 0/2 is for, what is it? Fast Ethernet 0/2 is for finance VLAN. Open this. So let me connect the cable back. So if it is both devices are different devices, I should use straight through cable. So here both devices are layer 3 devices. I'm going to use crossover. So manual connection. What is the port? Fast Ethernet 0/2 connected to this PC on Fast Ethernet 0/0. And one more port, Fast Ethernet 0/3, I believe. Yeah, Fast Ethernet 0/3 connected to this port. So see, switch ports, it's auto negotiation. Once you connect a devices, it becomes hub. No need to go and give no shutdown command. You try to negotiate and the port comes up on its own. That you should know. They'll ask a question. I mean, if I connect a PC into a port, I have to, admin up and down the port. No, if that is negotiate, the port is set to negotiation, and it will be up and running. And it'll, I mean, discuss about what is STP spanning tree protocols. But for this topic, just imagine that this is, the port is for set to negotiation and the port comes up on its own. Once there is an endpoint connected to the port. You see that I didn't do anything, the port come up, Fast Ethernet 0/213. If I give a command show IP interface brief, can I say this before I told you, right? The show IP interface brief, the protocol is down because I didn't connect the ports, active ports. Now, if you try to ping, do a self ping now. First packet will be a timeout. And you see this response is coming back. So in packet tracer, if you run this simulation mode, this is a very useful tool where when you practice with packet tracer, always turn on this real-time simulation. Because when we have a separate class where we discuss about the OSI model, we learn about what is the functionality of every layer. And here, if you see, you're seeing all this layer 2 informations, right? This is switch. And I told you it works only on layer 2. Always I used to say, right, this is a layer 2 device. what is source and destination it's sending. You get all this information inside. You see this packet flow you can actually follow with the real-time simulation. So now the port is up. So let me stop this simulation. So let me come back to real time. If I ping, you see the ping is faster than before. Because I am running the simulation, that makes the device slow. And let me reach this gateway ping 20001. Right, both the gateway, I should check 20001. It's reachable. So let's go do a testing very quickly. Let me assign a static IP address here, 10002, right? This is a gateway for this device. Show IP interface brief. 10001 is the gateway for this device. So I can assign 10002 here and the gateway is 10001. No need a DNS server for now. I give this IP address. Let me go to command prompt and ping 10001. What happens? Okay, let me initiate a ping again. Start. And I see this, the packet is going to the switch and it's reachable. This is ICMP echo and I'm getting an echo reply. This PC is sending an ICMP, sorry. This PC is sending an ICMP echo request from this PC to the switch, the gateway, right? Interface VLAN 2 10001. This is replying back with ICMP echo reply. So when you learn, just try to visualize and understand the flow and the protocols. That would be very helpful for you in the interviews and in for troubleshooting also. Don't just do the configuration. Always try to remember the concepts and the protocols. Try to understand. It's going to be very helpful for you to troubleshoot. So let me go to real time here. So I can ping. So what proofs here? So how do I check? Somebody saying, okay, you said you have created a VLANs and this is assigned. What is the proof? If you give show MAC address table, can you see this? This port is assigned to fast Ethernet 0/2, and this is assigned to VLAN 2. This is VLAN ID, VLAN 2. So let me go to this PC and assign an IP address for VLAN 3, 20.0.0.2 and 255.0.0.0.0 subnet mask and 20.0.0.1. I gave this IP address. Let me open the command prompt and try to ping the gateway 20.0.0.1. The first packet, it takes time. Now this PC is sending an ICMP echo request. See, for this echo request, I got an ICMP echo reply. Now let me go into the switch and give show MAC address table command. Can you see? This is 3. How do you check this? This 8B60 is the MAC address of this PC. You can see somewhere the MAC address. Sure, here somewhere I think we can see the MAC address of this PC. This command is very limited, so don't think we can see the MAC address of the PC here. If we config all, okay, this works here. So where is the physical address? See, 8B60. 8B60. So this is PC1, right? This is on VLAN 3. The same way, I'll go here and give IP config all the information. And this is there is a MAC address of this device, physical address 9172. So here 9172, it's on VLAN 2. So that's it, guys. This is a better understanding about the VLAN and a depth understanding about VLAN, I would say. This is how the communication happens between the VLANs, and this is the reason we need a VLAN. And the last point, they say this is as a SVI, switch virtual interface. That's how they call it, as switch virtual interface, because this is not physical. This is called as switch virtual interface. Show IP interface brief. All this L3 VLANs are switch virtual interfaces. See, this also switch virtual interfaces. Let's see here. So I try to cover the topic, what is layer 3 and layer. So since this is, it's pretty simple design, we got one switch and two PCs connected to it. This is just, we discussed about the access layer today. Not even a tier 2 model. This is just, I want to explain you how this communication happens, because I thought maybe in the beginning we had the same topology and explanation, but there are so many people there, they are new to networking and they doesn't know about all this. So that's the reason I'm giving you a in-depth understanding as much as possible. So they would be more familiar with that. The focus is everybody should understand. So since we have a limited time today, we can cover only the topic, this HTTP and HTTPS connection, how you can access the device through HTTP and HTTPS. And we worked on the lab, and we have seen the practical packet flow that happened between the router and the PC, how the communication happened, and we did some packet capture today. And today we got more understanding about VLANs and how this networks are separated. What is local area network and what is virtual local area network. We got the understanding better than before. So hopefully we will cover all this topic in the next class with some additional topics. Yeah, thanks everyone. I think everybody enjoyed the class today. So we'll have the next session, and I'll come up with some interesting topics. Thanks so much, guys. Thanks again.